In problem 1229, we are asked to outline a synthesis of the shown molecule from 2-propanol. So we're going to examine problems A and B. So using our general strategy, let's first describe what functional group is in each of these molecules. So here we have a secondary alcohol. Here we have a primary chloride. So this is a question of retrosynthetic analysis. So the arrow that we use to designate that concept is this arrow here. The problem is asking us to synthesize this molecule starting with 2-propanol. And this is 2-propanol. We need to supply the reagents and conditions that are going to take this and convert it into this molecule. So there's a concept called pattern recognition that we have to use here to see how these carbon atoms fit into this molecule. It may be tempting to say that this carbon here is this carbon here. However, it is not, because we have not learned any methods to activate an unactivated alkane carbon, such as this methyl group here. So the only other option to fit these 3 carbons into this molecule is this portion here. So what does that mean? That means we have to make this bond, which I'm dissecting. If we dissect that bond this way, we can use the lone electron pairs on this oxygen to think of how that bond is made. So we're thinking backwards at this point. If we draw the molecules that result from that, we end up with a carbanion, and a protonated carbonyl. We know that we can't have these 2 things exist in solution at the same time. So we need to think about what we learned in chapter 12. So we learned about Grignard reagents adding to carbonyl compounds. So we can transform this into a Grignard. Isopropyl magnesium bromide. And this molecule will just be our aldehyde. So we know we can add a Grignard to a carbonyl to end up with the alkoxide species. That can then be protonated upon acidic workup. So the question is, how do we convert 2-propanol into the Grignard reagent? So we learned from chapter 11 how to transform a hydroxyl group into a good leaving group. So in this case, we'll transform the hydroxyl into a bromide. So the conditions for doing that are phosphorus tribromide. So that's going to get us to the secondary bromide. And then we learn how to make Grignard reactions by treating alkyl bromides with magnesium metal. So we can take 2-propanol, convert the hydroxyl group into a bromide, treat with magnesium metal, that generates the Grignard reagent. We can then add that Grignard reagent to ethanol, this aldehyde, that ends up with our magnesiated alkoxide. and then we're going to work that up with acid to protonate, and that'll give us our secondary alcohol. So using the same type of reasoning per part B, we know that these 3 carbon atoms here are going to come from 2-propanol. So we're going to dissect this bond. So now that leaves us with the following. We have this carbanion and this carbocation. So we know that these are not species that readily exist, so we have to figure out a way on how to make these. We already know from part A that this can come from a Grignard reagent. But how about this? Where is this going to come from? So this is where we need to recall from chapter 12 that a 2-carbon synthon that reacts with Grignard reagents is an epoxide. We know that Grignard reagents will open up an epoxide ring. That's going to generate the following alcohol. So that's going to be protonated upon acidic workup. And then from here, it's a problem of converting a primary alcohol into a primary chloride. So we've learned conditions to do that. With thionyl chloride.